Welcome to Action. MovieStream Analytics produce the best picture with Oracle Cloud. This workshop's a little different than your traditional workshop. It's not focused on a single task or feature. What this workshop will do is introduce you to solving real technical and business issues, like deploying and loading a data warehouse, performing sophisticated analyses that uncover opportunities and challenges. And you'll use SQL, you'll use machine learning, graph, and spatial analytics, all from Oracle Cloud Infrastructure and especially Oracle Autonomous Database. MovieStream is a fictitious online movie streaming company. And they've had a lot of success. The customer base has expanded rapidly. They're generating massive volumes of structured, semi-structured, and unstructured data. And this data is providing them with real opportunities to help them accelerate that growth, to help them gain a better insight into their customers, to enhance their customers' user experiences, and ultimately improve profitability. Now, here is a simplified diagram of MovieStream's data architecture. Now, they're integrating data from a variety of sources, including enterprise applications, third-party data, and events that are streaming from their movie service. Now, the data from these sources is captured in Oracle Object Store in a data lake. Specifically, it's landing into what we call a landing zone of that data lake. Now, this landing zone stores data exactly as it came from the sources. So the data from the landing zone is then cleansed, it's transformed, and it's optimized, and it's loaded into the gold zone, or the curated zone. So an example of this transformation is sales data. So sales data is landing as CSV files. It's then cleansed, it's transformed into partitioned Parquet formatted data that's optimized for query in the gold zone. We're also going to transform and cleanse customer information. So all of that comes from the source landing zone into the gold zone. Now there's a third zone, which we call the sandbox. And the sandbox is really a playpen for data scientists to experiment with their data and to store their findings. Now, Autonomous Database serves as the access and performance layer. So data is either going to be loaded from the gold zone or the landing zone from the data lake into the warehouse, or that data can be accessed dynamically using SQL. Now, once in Autonomous Database, hundreds of analysts and data scientists are going to be performing sophisticated analyses, and they're going to get fast performance, and they're going to be able to use their favorite tools. So they could be using Oracle Analytics Cloud, Tableau, Excel, and more. So what Autonomous Database does is it brings the power of a multi-model platform to bear. So in case you don't know, Oracle Database supports multiple data types: traditional numbers, text, spatial, graph, JSON, and more. And Oracle Database can apply specialized analytics across all of these. And we're going to be using them widely across this workshop. Want to find a customer's local pizza place? Well, we'll use spatial analytics and their nearest neighbor algorithm to do that. You want to predict churn? We're going to use machine learning. Need to recommend products? Well, we'll try the whom to follow graph algorithm. So Autonomous Database provides a very powerful platform to do all of these types of analytics. It's all contained in this single platform, simplifying this access, providing a single way of securing all of your data. And it's just an extremely powerful platform. And the Forrester Wave recently classified it as the leading converged data platform on the market. So what are you going to be doing in this workshop and with Autonomous Database and the OCI data platform? Well, the first thing that you're going to do is that within minutes, you're going to deploy a complete data warehouse platform that can scale to your requirements. It separates storage from compute, which means you can then scale these independently, and you only pay for what you need. And you can use autoscale to burst compute when required. Next, you're going to use database actions to integrate Autonomous Database with the data lake. You'll be loading data from sources using this really intuitive drag and drop interface. Now, one of the things that the data load tools do to simplify the process is that they automatically derive schemas from the source files and then generate tables that can access that data. After integrating data into the data warehouse, we'll then use advanced analytics to analyze that data, right? So we're going to use the richest SQL language in the industry. We'll use SQL pattern matching. We'll do recency, frequency, and monetary analyses to find customers that are at risk, and you'll be doing a lot more. Well, we're going to find some customers that are at risk, and next, we're going to use machine learning to predict churn. So we know customers that we've already lost, but let's get in front of this, right? Let's now try to predict those that are at risk for churning. And we'll use machine learning to do that. And once we predicted those who are potentially going to churn, we're going to use Oracle Spatial to do a localized promotion. Everybody likes pizza, so what we're going to do is for those customers that are potentially going to churn, we're going to find local pizza places that we've partnered with to be able to produce these localized promotions. And then as part of that promotion, we want it to be compelling, right? So we're going to tailor those recommendations to each customer. And we're going to do that by using Oracle Graph. And we're going to make specialized product offers by saying, hey, we have customers. We know this customer is likely to churn. What are his viewing patterns? Well, it turns out that this customer is in this cohort. We're going to use Graph to define those cohorts. And then, well, what is the community watching that the potential churner hasn't watched? And let's make those recommendations. So specialized recommendations based on Graph. So let's begin and experience this inspiring true story about how a cloud-native, multi-model, multi-workload data warehouse platform saved the world from complexity.
Welcome to scene 1 of this MovieStream Analytics workshop. In these first couple of labs, what we'll be doing is creating and loading a brand new autonomous database instance. So in your workshop guide, we'll deploy and explore a little bit the autonomous database. Then we'll link it to our data lake, which has all of the data for our workshop, and we'll start loading that data into the database from the data lake. So the autonomous database, in addition to all of its well-established functionality, the fact that it can patch itself, upgrade itself, it can easily be backed up and restored and cloned, it's elastic and scalable and all of those good things. We're building a lot of additional built-in functionality so that the database can act as the central pillar to your cloud data platform. It can easily integrate with data lakes, and we can pull in and work with the data right directly into the autonomous database without moving it elsewhere, so that we can do powerful machine learning, graph analytics, and all sorts of other things, spatial analytics. And this workshop takes you through some of those things as a kind of opening tour. So in this first part of the workshop, we'll create a brand new autonomous database. We can do that in just a few clicks. You can observe as you go through the provisioning process how easy it is to pick the initial number of OCPUs, to pick the options to auto scale that, to pick the amount of storage, and all of that can be done in just a few clicks of the mouse. Then when we have the database instance created, we'll create a new user for the purposes of the workshop. Again, we'll just use our browser to do that. We'll tick on a few of the options we need, graph, web access, and OML for that user, and we'll make sure the user has enough table space. That's all we need to do. Then once the user's created, we can start loading data in from cloud storage. Now, in this case, the workshop uses data that's on Oracle Cloud Infrastructure Object Storage, but the data lake could just as easily be on Amazon S3, on Azure, or on Google Cloud Platform, or even any combination of those. And it wouldn't matter, we'd still be able to load the data into the database or even link to the data in those external data lakes, just using the simple built-in tooling directly available in the UI. And then the final step of the workshop is just to very quickly load in the rest of the files through SQL. It uses exactly the same underlying DBMS Cloud APIs to load the data in from cloud locations. Okay, so the very first step of the workshop is just to create an autonomous database. We're going to call it MovieStream. You can give it a name that you choose. The name is not important for the workshop, but just make sure it's something memorable. We can choose the data warehouse workload type and on shared infrastructure. You can tick on the always free option if you want to. That is sufficient for the workshop, but normally we'll just leave these options as they are. The default 1 OCPU will be sufficient. If you want to create more, you can. And make sure you just type in a password that you can remember for the rest of the workshop. Once you've done that, click on the license included option and the create button. After a couple of minutes, you'll see the database is now available to use, and you can access all the menus to see the kind of ease with which you can do potentially previously difficult operations like cloning the database, managing the encryption key, moving it, and things like this. But for the rest of the workshop, we're going to focus on the tools that are built into the database. So we'll go into the Tools tab, and we're going to click on Database Actions. And from there, we're going to start the process of creating a new user for the rest of the workshop. And we'll also use the Database Actions page for a number of the other items as we go through the labs one at a time. So the first thing you need to do is log in as that admin user that you created when you first set up the database. And click on Database Users under Administration to create the new user. Click on the Create User button. Now here we just need to specify the MovieStream user, give it a password that you'll remember. And now we just need to click on a few options. So we need to click on Graph, Web Access, and OML, and Unlimited, and then we'll create the user. Now the user's been created, we just have one more thing to do as the admin user. Just go into SQL and paste in from the workshop guide those additional SQL statements that just grant that user a few more privileges in the database. Once that's done, we can log out as admin and sign in as our MovieStream user. And this is the user that you'll use for the rest of the workshop. Now straight back onto our database actions page, and we can start loading data into the database from object storage. Now to set up that link to our data lake, we need to click on Cloud Locations. Then click on the Add Cloud Storage button, and we're going to call this MovieStream Gold, because that's the name of our gold area in our data lake that contains our curated data sets. Now this is a public bucket, so we don't need credentials. We can just paste in the URI. Let's just test that. That's fine. and we can create that link. That's all there is to it. Now, once we've got that link to our data lake set up, we can go back to data load and we can see the options available to us. We could load data in from that cloud storage. We can link to data from it, or we can feed data in continuously based on changes in the data that we're notified about. For the purposes of this workshop, we're going to load data from cloud storage. You'll notice that we could also load data like Excel files or CSV files from our local machine here, or from another database that we have a link to. In this case, we're going to select load data from cloud storage. And now you can see we can browse the contents of our cloud data lake. Now for the workshop, all we need to do is drag over a couple of the folders from that data lake into the right-hand pane here. Now you'll notice that you get a dialog box. Do we want to load all the one objects in the customer contact folder? So, okay, in this case, we've only got one file in that folder. But you can imagine in big data scenarios, we often have lots of different files that are coming in representing the same data and in the same structure. So very often we'll want to load those into a single table. So that's what we can do by dragging that folder across rather than the individual file. We get that option and we can just press OK. That will bring up a load task for our customer contact folder. Let's do the same for genre, add that in. And we want to click the OK button again. Now let's have a look at the settings for one of these tasks. Click on the pencil icon. You can see that the hard work is really done for you. So these CSV files have been understood by the load tool, and it understands the data types and so forth, and it's going to create columns automatically for us based on the headings. So we can click on the close button, and if we're happy with the mappings for both these files, which should be correct for the lab, we can just click Start to run the data load job. And about 20 seconds later, you'll see the green tick icons on both of those tasks. That means those tables have been created and loaded with that data from object storage. Nice and simple. So the last stage of the lab is just to go into SQL and to paste in a script that comes with the lab, which will load the rest of the data for the workshop. And this is just done to really just make things very, very quick for the purposes of spending the time doing the fun stuff, analyzing the data. So we have a script here. All we just do is click on the Run Script button, and that will load all of the rest of the data for the workshop. Once the script is finished, just click on the refresh button to see all the tables that have been created. And you should have a list of tables that looks a little bit like this with cust sales and genre and movie and so on. And that completes the first couple of labs of the workshop. The next stages will go on to analyze the data and to perform a number of different other operations that are available in the autonomous database. Thank you.
Welcome to this lab on analysing movie sales data with SQL. My name's Keith Laker. I am your host for this lab, and hopefully you've arrived at this lab having provisioned your autonomous data warehouse. You've loaded the data with the labs that Mike did, and you're now ready to get started with SQL. So the good news is everything you need is already inside your autonomous data warehouse. You're ready to go, and what we're going to show you in this particular lab is some specific SQL features. We're going to start at a very basic level, how to join data sets together. You're then going to look at how to extend that knowledge and add some calculations in. And then we're going to show you how to effectively create lots of calculations at the same time and do a very sophisticated technique called binning. But don't worry, we're going to explain it all to you. What you'll see as you walk through this lab is, firstly, SQL is pretty simple. It's easy to understand language, but it's very rich. And as you go through this lab, as we sort of pick through the layers of this lab, you'll see that you've got access to a very, very sophisticated language to help you solve real-world business problems. So you're going to explore a lot of the capabilities of SQL. What you'll notice is your queries run really, really fast in Autonomous Data Warehouse. That's because we've got a lot of built-in performance optimizations that happen behind the scenes. One of those optimizations we'll give you a sneak peek into, which is called Result Cache. You'll have a quick look at that as part of this lab. We'll then get into how you bring together different data sets, and in effect how you do joins using SQL, and we'll step into that. We'll also look at how you can take queries and join queries together using something called the with clause. What you'll notice as you walk through this lab is essentially it's a whole series of building blocks. As you move from each step to the next one, we're taking that knowledge that you've just acquired and extending it by adding additional features in. And everything that you learn in the SQL lab, you're actually going to take a lot of this knowledge and use it in the next lab, which deals with semi-structured or JSON data. So this is a good starting point. Okay, your data set. So you loaded some data in the previous labs, or maybe you jumped straight into this lab and you used the little package that we have which loads all the data automatically for you. But essentially what you've got is a model inside your data. And that model is made up of obviously sales data that comes from 4 key elements. So the first element we'll look at, say, is a customer. So a customer will come in to our platform and maybe they'll look for a genre, say thriller, and they'll find all the movies that belong to the genre thriller. And then they'll decide to rent that movie, and that gives us a timestamp. We can bring all of that data together to log that as a customer sale for a thriller movie on a particular day for that customer. Now, how we access all of those elements is driven by the type of join that we do on those 5 tables. And we can either do simple joins, whereby, for example, we might filter on thriller and only show me the movies that are thrillers. And that's a typical type of join. Most of the joins that you do with SQL are that type of join. So if a movie's not a thriller, you don't see it. However, there are times when I actually do need to see instances where in the main, what we call the dimension, for this, let's take an example of the time aspect, where maybe I don't have a sale on a particular day. And that would be useful to know. And to get that level of detail where I have all of my time elements and I can see the sales by time, and I can also see the days or the months or the quarters where I don't make a sale, I create what's called an outer join, because for those days there would be no record of customer sales. So we're going to walk you through these different types of joins that you can do, and you'll see the different types of output that they generate and how and when to use those different types of joins. Having understood that concept, we can then move forward to start analysing our data. So now we want to do some aggregations. So we don't sort of want to be at the customer level. We want to start aggregating this up, maybe by quarter, maybe look at genres by quarter. So we need to do what's called a sum operation. And to help with some of the formatting, we'll use a round function. And you can see you can nest these functions. So I've got round followed by sum. When I'm doing some of these operations, I also maybe want to compare 2 different, in this case, points in time, i.e. what I sold this current year versus what I sold in the previous year, and be able to understand where I've increased my sales in the current year versus the previous year. To do that, your Autonomous Data Warehouse has things called window functions. And in this case, you're going to work with something called the lag function. We'll walk you through all of the code that does all that as part of the lab. And then the last step is you're going to look at, having done joins of data sets, actually you can do joins of queries. And to do that, where I've got multiple types of queries, I use a with clause. And to do this, we're going to use it on a typical retail business problem. We want to understand who our most important customers are. And there's a particular type of query that does that. It's called an RFM query. And the RFM stands for Recency, Frequency, Monetary. I want to understand who are the customers accessing my system. When did they last access the MovieStream platform? That would be the recency. I want to know what level of activity they have on my movie streaming platform, i.e. the frequency. And most importantly, I want to know how much money they're spending on the platform renting movies. So we look at the monetary aspect, and we create these three queries and join them all together to be able to identify our most important customers. And we do that with something called the with clause. And we'll walk you through that. At the end, what you should see is you've been through a lot of queries. They've built up very nicely. You can see that, most importantly, SQL is a very easy language to understand. It's very fast in Autonomous Data Warehouse because of all the optimizations that are happening behind the scenes to automatically make sure that your data runs, or your queries run, as fast as possible. And also you've got access to a lot of very smart functions that help you answer real-world business problems. If this has whetted your appetite, maybe you want to go a bit deeper into SQL, see what other business problems you can solve. We have a huge library of videos that walk you through how to use SQL to solve different business problems. And our SQL experts like Connor McDonald and Chris Saxon have got lots of great examples here on this site. It's all free. Use these and you'll be able to go even further with SQL. And that's it. It's a wrap. I've been your host, Keith Laker. I hope you enjoy working with SQL in this lab, analysing your movie sales data. Have a great time, and thank you very much for listening. Welcome to this lab on working with semi-structured movie data. My name is Keith Laker. I am your host for this particular lab. And in this lab, we're going to show you the power of JSON or semi-structured data within Autonomous Data Warehouse. The good news is everything that you need to work with JSON data is already part of your Autonomous Data Warehouse. So it's nothing to deploy, we're ready to go. The first step we're going to show you is writing some very simple SQL notation for working with JSON data. Slightly different to the SQL that we used in the previous lab in its format, but what you'll see is the structures that we had in the previous SQL lab. If you haven't already done it, I recommend maybe after you finish this, go back to the previous lab and work through the SQL features. But you don't need to know a lot about SQL to do this lab, so it's fine to just dive in at this point. But JSON has some very, very sophisticated structures built into it. And we're going to show you how you can work with those sophisticated structures. We'll come to that in a minute. The key takeaway here is, again, SQL is very simple to use, but it's also very rich and it's a very sophisticated language. And you're going to do some really quite deep analysis here as part of this lab. It's going to be very cool and very exciting. But let's just have a quick look at what a typical sort of semi-structured JSON data looks like. As you can see here, there's sort of different parts to this. So we have one particular element here. This is the data for a particular movie. That movie is called Gatabait 2, and you can see there's different pieces of information here. So it was made in year 1998. You have a cast, and there's 4 key people, and this element of cast is kind of where JSON diverges from other types of data that you might be used to, in that you'll notice I've got cast and I've got 4 people here, and this is in JSON terms what we call an array. So that's the first part. If you look below that, we look at the crew. We've now got another array which is a little bit more sophisticated again, because I've got the concept of crew, and there are different types of crew. So I've got producers, and I've got 2 producers. I've got a director as a job, and there are 2 directors. And of course there's a writer, and in this case we've got 1 writer. So there's a lot of elements in here, and what we need to be able to do, and SQL in Autonomous Data Warehouse allows us to do this, is to work with all of these different elements, whether it's just extracting the year 1998 or being able to work individually with each of those cast members by pulling out their name, whether it's Jocelyn Boudreau or Jan McKenzie and so on. And you're going to get into these arrays and work very quickly and easily with them. The starting point is going to be just to get you to understand the transformation that goes on inside Autonomous Data Warehouse. We're going to use something called simple dot notation. So it's going to look fairly similar when we write a query, or when you write a query, to the SQL that you used in the previous lab. It's just tweaked a little, and what that notation does is allow us to generate results that transform that semi-structured data into something more like what we're used to. In other words, a table containing columns and rows. Having got that concept, we can then move on to do some more deeper analysis. And we're going to focus on trying to understand what happens around the Academy Awards. So we know it's a great time for the movie industry. There's always sort of lots of news and exciting things going on. But what does that do to our sales? It'd be interesting to understand, does a movie get more views after it's won an Academy Award compared to before? So we'd like to be able to write a query that shows us that information. How many views did it have before the award versus how many views did it have after the award, and what was that pickup? What was the percentage increase? This could be quite a challenging question. And don't forget, we're working with semi-structured data as well. So we're going to work on a query to find the sales for movies that have won the Best Picture Award and do some deeper analysis on it. And that's kind of the key part of this particular lab. So what you should see is that, we're working with a different type of data, but most importantly, our queries are running really, really fast inside Autonomous Data Warehouse. Again, we've got lots of optimizations for query management that are running behind the scenes for you. But the good news is the types and the structure and format of those queries are really simple to understand. And as in the previous SQL lab, there's all of these super smart functions that you can apply to that data set and get back answers to quite complex business problems. Hopefully this all whets your appetite and you're thinking, oh, I'm sure there's a lot more I could do with JSON data, and there is. We have this huge library. It's completely free, where you can go to get more information about how can I work more deeply, what else can I do with JSON data. And we've got lots of experts who contribute information to this, like Jeff Smith, as you can see on the screen there, who will help you get even more insights into working with JSON data. So as I say, it's completely free. Enjoy it. It's a wrap. I hope you've enjoyed this quick walkthrough. Have fun with this new lab, working with semi-structured movie data. My name's Keith Laker. Thank you very much and have a great time.
Welcome to Scene 3 Oracle Machine Learning. In this lab, we're going to use Oracle Machine Learning and lots of its capabilities to predict customer churn. Depending on the work done on the previous labs, we're going to learn how to identify potential churners so that we can use them for promotions and for the recommendations coming up on the next labs. Oracle Machine Learning is included in all Oracle databases, and especially in Autonomous Database, it includes a few additional components that we're going to see today. So OML has a scalable and sophisticated data preparation components for all of the machine learning requirements. Everything is in there, including rich SQL language, Python interfaces. There are different database operators, and all of those can support data scientists and data engineers. We also brought the algorithms to the data, so the algorithms run at the scalability of the database. So they are distributed, they are running in parallel, and they can build and score in parallel very fast. The automated machine learning or AutoML technology is also included, and this allows you to actually have a tool that helps you choose the best model for the problem at hand. So citizens data scientists can gain access to these powerful algorithms. And finally, we're going to see how OML reduces time to market for ML deployments, because we can do scoring through SQL, through Python, REST APIs with sub-second scoring responses for real-time applications. And that enables integration with machine learning results very easily for third-party applications. So the first step is looking at the churn. In this case, we're trying to predict churn, so estimating in the future when a customer would stop using our service. So for us, we need to look at the past behavior of customers that actually left and all the other customers that stayed, and try to feed that data into the algorithm so that the algorithms can differentiate people that stayed from people that left. And then it will be able to then predict in the future who's going to leave and who's going to stay, so that we can focus on the ones that are going to leave and try to offer something that will keep them. In our case, we're going to aggregate data monthly so that we can see the behavior from month to month, and then we can identify whether a customer is going to churn in a couple of months ahead of time. There's also data pivoting aspects to make sure that we can see if a customer uses credit card, has any influence versus a customer using other forms of payment, and then comparing customers that use different devices to watch the movies and things like that. And finally, the definition of churn, right? That's normally the most complex business process that needs to happen, which is who is actually a churner, right? Is a customer that stops using the service completely, or a customer that just haven't watched the movie on the last month? So what we're going to do for the current lab, just like depicted here, then we're going to build the model using 12 months of data measured from October 2019 to October 2020. And then we're going to apply the model to the current data that we have to try to estimate the probability of a customer to be a churner in February of 2021. So when you go back to the instructions, then you're going to see that Lab 5, use Oracle Machine Learning AutoML UI to predict churn, is right here. And basically at the beginning of the sections here, we're going to see just a quick introduction. And if you look at the tasks, we have basically 4 tasks. The first one is to understand customer churn and access the Oracle Machine Learning AutoML UI. Then we're going to run the experiment and explore the results. And finally, we're going to deploy the model and score a new table. So the first task then is looking at all of that information. Is just revisiting what we were just talking about in terms of the what kind of data and what kind of table makes sense for us to predict churn. And the first steps are going to be to go through the current autonomous database that you have and learn how to get to the AutoML UI. So let's see how we do that. So from the details page of the autonomous database, you click on Service Console. And in the Service Console, you're going to click on Development and then on the Oracle Machine Learning Notebook style. And in here, you're going to log into Oracle Machine Learning Notebook using the MovieStream user and the appropriate password. And that's going to take you to the home page of Oracle Machine Learning. From the home page of Oracle Machine Learning, we're going to click on AutoML on the left-hand side in the Quick Actions. And in AutoML Experiments, you see there's none there, so we're going to create one. And basically, we're going to give it a name. So we can give any interesting descriptive name and also a comment. And then we're going to click on Data Source. We need to find the table that actually represents the churner. So it's a MovieStream_churn. And we're going to say OK. So now we can actually see that if we scroll down in the screen, we see the features that are available in that table. And we see there are lots of transactions on previous months, discount, genres of movies, how many movies that people have watched. So we're going to select the prediction column, that is the is_churner, and the cust ID as case ID attribute. And on the additional settings on the left, we're going to actually reduce the number of maximum top models to 2, and we're going to change the data service level to high, just so that we can run this as fast as possible. We are ready to start our experiment, but before that, this is just an idea of the different algorithms that are contained in the Oracle Machine Learning for in-database purposes. Basically, they allow you to do a lot of the multiple interfaces, so they are accessible through SQL, through Python, and we also have a scalability in our favor there. Moving to task 2 is where we're going to see how to run the experiment. And then we're going to be evaluating the different models that come out as the best ones, and we're going to learn how to deploy them on task number 3. So here in task 2 is where we're going to see the experiment and all the steps that it requires for us to just start that experiment and then evaluate it. We're going to be waiting for that to run, and we're going to see all the components. We're going to see the models, we're going to compare them, and then we're going to see the model statistics and the leaderboard, and we're going to learn how to evaluate and look into that data that it returns. So let's start the experiment. We select faster results because the better accuracy will take more time. And then once it's running, we can see that it starts selecting the algorithm, and then the process keeps going. You can go back to the experiments, and you're going to notice that it's running, right? So that means it's running asynchronously, so you don't have to look at it while it's running, but we can go back, and you can see that now it's all the way down to the model tuning, and it's going to tune the models that it found the best ones, decision tree and random forest in our case. And once it's done, it's going to actually add a feature prediction impacts to each model. So if you scroll down now, we have a new column there, an importance column that shows us the relative importance of the columns for the problem at hand. But each model has its own specific feature impact. So now we click on the decision tree, and that screen opens up. So we can see the specific attributes that were determined: age, gender, the genres, different household sizes. And then if we click on confusion matrix, we can see that the greens are the good ones. So looking at the explanation in the labs, you can see that the diagonals sum up to 95.42%. So the model was correct. And then we got a problem with 3.59% of the customers that we thought they were going to churn and they didn't. So they're going to just receive offers and free offers, and they are already loyal customers. And there's less than 1% of the customers that we did not detect that they were going to churn, but they did. So it's a small number. So the last step we're going to do is actually we're going to click again on our leaderboard in the model, and then we're going to click on rename. So you give the model a new name, just so that we can recognize that in SQL later. And we say OK, and to the top right, you're going to see an indication that the model was successfully renamed. So now at task 3, basically what we're going to see is that you're going to have to download the Scoring Customers with Churn Model notebook. This is a JSON file that is available to you. So you have to download that and store it in your local computer. And we're going to select then the hamburger menu here and the notebooks. And with that, we're going to see that we have the notebooks. So there are going to be probably no notebooks here. And you're going to be able to click on import, and then you're going to import that file that we just downloaded. With that in hand, then you're going to be able to click on it and open that notebook. And then inside the notebook, what we're going to do, the first thing is we're going to select the right interpreter. So we're going to click on that gear, select interpreter, and then we're going to run the entire set of paragraphs. So with that, basically we're going to get the output. So the output is going to be the scoring. The code there is already there is going to score that. There is an example of that code and how to run it if you wanted to connect it to your own instance and run it on SQL. But basically, there's a 1% sample of the output, and then you're going to be able to see the customer ID, whether the customer will churn or not, and then the probability to churn is going to be displayed there. And that's going to be the end of the Oracle Machine Learning AutoML UI to predict churn lab. So as we saw before, then we have to click on the hamburger menu and go to the notebooks. And in there, you might have no the previous notebook. So we're going to click on import, and we're going to import that notebook that we just downloaded, the JSON file that we downloaded before. And now when it shows up, we can just click on it to open it up. So when it loads, the first thing we're going to do is check for the interpreter. So we have to go all the way to the right on the top, click on that gear, and maybe drag that medium up top, and then click on run all paragraphs so that we can run the entire notebooks. When it runs, then every paragraph is going to be executed, and we remove a table if that exists before, but then we create a table called latest potential churners, which is going to contain the churn prediction and the churn probabilities. And then if we preview that table, basically you're going to see that we have customer IDs, whether the customer is going to churn or not, and the probability to churn, which if it's larger than 50%, then we say the customer is going to churn. Otherwise, the customer is not going to churn. And we're ready to proceed to the next lab using that potential churners table. To learn more, we have Oracle Machine Learning Live Labs and several different resources. So we have a lot of machine learning live labs available that you can go check using the QR code here on top. There are Oracle Machine Learning notebooks and template examples that come with the tool. You have the GitHub repository with all the samples we have available, and Oracle Machine Learning Office Hours Weekly, where we show you several different use cases, and everything that is new about OML is always shown there. So as a closing thought, basically Oracle Machine Learning has key attributes: the automation, the scalability, and making it production ready. And these are the 3 key attributes that OML brings to make machine learning in production a reality. Thank you for watching.
In this lab, you're going to use the spatial features of Oracle Autonomous Database to help create localized pizza offers based on spatial proximity analysis. The context here, of course, is spatial. Everything happens somewhere. All the business information that we manage ultimately relates to activities, customers, incidents, events, transactions that happen somewhere. The ability to relate and analyze all that information based on location holds tremendous value. Are events or incidents located within a certain proximity of each other? Which location is nearest to something else, which is aligned with our lab here? Which pizza location is nearest to customers? Which tax zone are we in? Are we within a flood or hazard zone? And on and on and on. Oftentimes, location relationships are really the only relationships between disparate pieces of data. There's no natural key to join between. in many cases. However, proximity and containment creates that association between data sets, and there's tremendous value in that. Within Oracle Autonomous Database and Oracle Autonomous Database Shared in particular, there's a set of native spatial capabilities whereby you can store spatial data, points like geocoded address locations, lines like utility alignments, polygons like sales territories, for example, natively within the database with a native data type. In addition to that, we can store, in addition to our native spatial data type, JSON representations of that data, as well as store geospatial imagery, satellite imagery, drone imagery, and so forth. Along with the ability to natively manage that kind of information, we have a vast API for processing and analyzing that information through standard SQL and PL SQL. So in the example that we see here at the top, we're able to ask a proximity question with standard SQL. Say, for example, we have policyholder locations for an insurance company in a table, and we have information about a projected hurricane path. And we can use standard SQL to identify the policyholders that are within, in this case, 10 kilometers of that projected hurricane path. Now, there's dozens and dozens of packages containing hundreds of various operators, calculations, measurements, all sorts of spatial operations that we can do natively in the database. We'll see some of these in the lab that you're going to do. There's also a no-code or self-service application that is provided along with the database to provide access to those same features for spatial data management, processing, and analysis, as well as map visualizations, creating maps. And that's something called Oracle Spatial Studio. And that's a free tool. It's available on the Oracle Cloud Marketplace, and it allows users to effectively drag and drop to select data, upload data, visualize it on a map, and do all the kinds of analyses that you would otherwise do through code in the database. Now, the very first version of the MovieStream workshop that you are working through today does not include Oracle Spatial Studio, but I wanted to make sure that you are aware of it. And at the end, when I show some links, you're going to see where you can learn more about it and get a jump start even before we introduce the second version of MovieStream. Another very important aspect of the spatial features in the database, in Autonomous Database in particular, is the fact that they live among all of the other converged features of Oracle Database. And the converged features of Oracle Database include a wide set of capabilities that go beyond the traditional forms of storing and querying relational data. So that includes, in addition to spatial, things like graph, native JSON representations, columnar data stores, native REST enablement, and so on and so forth. And the beauty here is that each of those multi-model sorts of capabilities are not built through separate specialty databases. They're all part of the Oracle database, and again, in particular, Oracle Autonomous Database. So the power of spatial really is amplified when you start to combine it and bring it together with and integrate it with these other converged capabilities. Now, there's a wide variety of, in addition to these sort of advanced multi-model capabilities, there's a wide array of just traditional powerful features of Oracle Database, unique features of Oracle Database, that spatial has been engineered to take advantage of seamlessly. So while these are not spatial features, they're powerful database features that spatial knows how to take advantage of. And those are things like the way that Oracle Database handles partitioning. Well, spatial knows how to work with partitioning natively. So you can have spatial partitions with their native individual spatial indexes. High availability, sort of active standby. Well, Oracle Spatial is integrated with that so that you can have high availability that is sort of spatial aware. And another one I'll mention that is part of the lab that you will do is something called function-based indexes. where you can create an index on the result of a function. And that's a powerful database feature used all over the place, but Spatial knows how to take advantage of it. And as you'll see when we get to the lab, you will, because it means that a function that generates geometry can be indexed. You can create a spatial index on that, and that provides a lot of value in terms of agility and the ability to index and process large amounts of spatial data without ever having to physically build a geometry column. So just to summarize some of the key resources available to you to learn more, here at the top we just have our entry point into the spatial features of the database. So this will take you to the portal from where there's all kinds of other information, documentation, and everything else available. A few details within that worth calling out. First of all, live labs. You're in the MovieStream live lab workshop, so you know about live labs, but there's 3 in particular that you could look at as well that are specifically around Oracle Spatial and Oracle Spatial Studio. So I'd encourage you to look for the workshops with those names. Ask Tom is a webinar series that are recorded, and there is a whole series of Ask Tom webinars on lots of spatial topics. So I would encourage you to follow those. And finally, we have our Oracle Spatial blog with more information, recent announcements, etc. So the lab that you're going to do is around associating customers with the nearest pizza shop location, specifically a set of pizza shops that we've entered into a partnership with for a promotion. The idea is that the machine learning exercise would come up with the customers that are at risk of churn. This lab determines for each customer which is the closest pizza shop, if there's one within a reasonable distance. And then those 2 things would be put together to basically say for the customers at risk of churn, we now know which pizza shop to create a promotion for. So what you will be doing in this lab is as follows. You're going to be working with the customer contact table and the pizza location table. Each of those includes coordinates. You're going to begin by creating a function that converts those coordinates into a geometry, just a general purpose function. You will then create some standard spatial metadata for each of those tables, metadata that's required of tables that have spatial data that's used for spatial operations in the database. You will then create a function-based spatial index on both of those tables, which I mentioned previously is a powerful database feature that Spatial is able to take advantage of. And then once you've done those 3 steps, you'll run a whole host of what we call nearest neighbor spatial queries, proximity queries. And you'll see the full sort of complement of different ways in which those kinds of queries can be run. And you will, at the end of it, finally run a big nearest neighbor join query to determine the closest pizza shop for each customer when that customer is within a reasonable distance of a pizza shop location. I hope you enjoy the lab and it encourages you to look more deeply into spatial, and thank you for your attention.
Hello, and welcome to the lab where you will use graph analytics to make movie recommendations for customers. In this lab, you will use graph analytics to make movie recommendations for customers who have been identified as churners in the previous labs. So let me start with an overview of graphs. So modeling your data as a graph enables you to make explicit the relationships between data entities. And this allows you to apply graph algorithms to your data. For example, you can identify communities within your data. You can identify important vertices, that is vertices which are highly connected. You can find paths in your data and so on. And when you represent your data as a graph, you can look for graph patterns and you can query your data to identify these patterns. And this makes the ability to identify patterns and the ability to do analytics makes the graph data model really powerful. And you can model almost any data as a graph. In the example on the left, you have bank accounts, which can become vertices in your graph, and any relationship between them can become an edge. So when an account transfers money to another account, that's a relationship, and that can be an edge, that's a cash transfer edge. On the right, you have customers and products as two different types of vertices. And when a customer buys a product, that's a relationship between two vertices, and that becomes an edge. So any logical connection between data entities can become an edge in your graph. And in the property graph data model, edges and vertices can have properties associated with them. And you can model your graph from any data set right in your Oracle database. And after you model your data as a graph, you can use a graph query language to find paths like variable length paths, fixed length paths. I want to see whether there is a path of length 4 between these two vertices. Or you can find cycles. Are there 3-hop cycles, 4-hop cycles, and so on? Or you can look for specific patterns that you can represent in your graph query language. And in the algorithms, you have a variety of algorithms that you can apply to your graph to detect communities, to find important nodes, for example, using the PageRank algorithm. You can do graph machine learning on your graph. You can analyze the structures in your graph, and so on. And customers are using this to build a variety of interesting applications. In this example from the financial services industry, they use path analysis to identify whether cash transfers between two accounts are going through a lot of intermediate accounts. So that's something they would like to flag and investigate further. In network management, you can use graphs to do what-if analysis, like what happens if a node goes down. And also, there are some interesting work being done around using graphs to detect malicious traffic. So rather than looking at IP addresses and IP packets as individual entities, you can look at how the IP packets are flowing between nodes and create a graph from that and use that to detect similar patterns. In manufacturing, graphs are used to model bill of materials, so we can do what-if analysis, what happens if the design of a component changes, which are the other components that would be affected, and so on. And you can also use graphs to make product recommendations, which is what you will be doing in this lab. So a summary of the graph features is here. And one key feature is that you can create a graph from database tables. So your business data is probably in database tables, and you can create a graph right there. You don't have to move your data to a specialized database just for creating a graph. And the Oracle Graph feature includes an in-memory graph server for highly scalable graph analytics and graph querying. It includes a property graph query language, which is a SQL-like language for querying graphs. And by SQL-like, I mean you have the select clause, the from clause, the where clause, the count star, and so on. And in addition, you have the ability to specify a graph pattern, the ability to specify vertices, edges, how they're connected to each other, and so on. Oracle Graph also includes over 60 pre-built graph algorithms for detecting communities, identifying important nodes, doing path analysis, and more that can be invoked using a Java or Python API. And all of this is built on Oracle infrastructure. And when you're using Autonomous Database, you can use the Graph Studio feature to get a fully managed service that includes all of these features. And the Graph Studio feature of Autonomous Database is fully managed, and it automates many of the graph creation processes. For example, you can say that these are the tables I want to use in a graph, and then it'll create the graph for you, and you'll see an example of that in the lab. And the Graph Studio can be invoked right from the Autonomous Database console, and you can get started in minutes to model your graph and do interesting analytics and queries on your graph. So it's very, very easy to get started with using graphs when you use the Graph Studio feature in Autonomous Database. So that's what you'll be using in this workshop, the Graph Studio feature of Autonomous Database, but you also have graphs available in other deployment options. For example, if you have a user-managed database on premises, you can use the Oracle Graph feature there as well. So now coming to this lab, there are several different tables that you've been using as part of this workshop. In this lab, you'll be using 3 tables: the customer table, the customer sales table, and the movie table. And the customer sales table, of course, tells you which customers have rented which movies, and that becomes the edge table. So you have customers a vertex table, movies a vertex table, and cus sales is the edge table. And we'll actually be using a subset or a sampling of data from these tables to create a graph. And then you will use the whom to follow algorithm, one of the over 60 pre-built algorithms that are available. And you use that for a particular customer who has been identified as a potential churner. And for that customer, you identify the community that they belong to based on other customers who have similar movie watching habits. And then based on this other community, you make a recommendation for this customer that the customer will probably like, but has not seen yet. So it's a simple bipartite graph with customers, movies, and customer sales representing the edges. So in this workshop, as in any application using graphs, you would create a graph, you query a graph, you analyze a graph, and then you visualize a graph. So these are the typical operations, and I hope you enjoy doing them in this lab.